Hello everyone, I am Dr. Krishna Sarker, Department of Electrical Engineering. Here in this session, I will be going to discuss about Introduction to Linear Controlled Systems. Lecture series on Linear Control Systems and lecture number 01. So our topic's name, Introduction to Linear Control Systems. In overview, what is overview? Introduction to linear control systems. What is linear control systems? Basic definition of linear control systems. A control systems must have elements of good control systems, components of control systems, requirements of a good control systems. So this is our overview, introduction to the linear control systems and what is linear control systems, why linear control systems. So linear control systems. Control systems means control plus systems. So what is control? What is systems? Systems in this case, system may be electrical, mechanical, electronics, hydraulic, pneumatic, any type of system you can use. So this is the basic or simple block diagram. So this is the control system block diagram, and this section mainly input part, and this is the output part. Input may be step, ramp, parabolic, impulse, sinusoidal, discrete, any type of input you can apply. And control system in this section, this is the process or plant, and this is the output. Sometimes this input also called reference input. So simple block diagram of a control systems. A control system is a system or scheme which provides the desired or preferred response by controlling the input and output. The output is controlled by varying input. So input controlled, output is controlled. This is the output, and this output is controlled by varying input. This output is controlled by varying input. This input vary with some mechanism, and this input vary with some mechanism. So again, this is the block diagram. So controlled input, this is the control input section, and this is the control system block diagram, and this block mainly process or plant, and this is the controlled output. So cause and effect relationship between input and output of a plant. This is the cause and this is the effect. A control system is an interconnection of components forming a system configuration which provides the desired output response. The control system is very important for all engineering students. The first significant control device was James Watt's 5-volt governor in 1767. This is the automatic generation control part. First significant control device was James Watt's 5-volt governor systems. Basic definitions of the control systems. What is control? Control system is control plus system. So what is control? The meaning or significance of control is to regulate, direct, or command a system so that the desired objective is obtained. Again, what is control? The meaning or significance of control is to regulate, direct, or command a system so that the desired objective is obtained. And what is system? It is an arrangement of combination of different physical components that are associated or related in such a manner as to form an entire unit. This is a system. And what is controller? It is an inbuilt or external of the system which control the plant or process. Controller is the brain of the arrangement. So controller is the brain of the arrangement. It may be a computer program, electrical, electronic, pneumatic, mechanical device, etc. So this is the basic definition of control systems and controller. Then another definition, what is actuator? Due to the actuator mechanism that causes the plant or process to provide the required output, or it provides the motive power to the plant. And what is actuating signal? Actually, this is the basic block diagram. This is the feedback signal, and this section reference input, and this is the error signal, this is the control unit, and this is the actuator. So what is actuator? Due to the actuator mechanism, the causes to plant or process to provide the required output, or it's provide the motive power to the plant. So actuator output signal actually plant or process output signal. And what is the actuating signal? The signal that is the difference between the reference input and the feedback signal. So what is the reference input? This is the reference input. This section reference input. So this section minus this section is the error signal, and this error signal controlled by control unit, and this is the input of the actuating signal, and this actuating signal control the plant or process system. This is the actual mechanism. So actuating signal, what is actuating signal? The signal that is the difference between the reference input and the feedback signal. It is the input to the control unit that causes the output to have the desired value. So this is the feedback control system or closed loop control system. This is reference input, and this is the overall output. Input or controlling variable, the applied signal generated outside the plant or exciting signal that is applied to a control system, that means plant, process, etc., to get a specified output is called input. And input causes the plant to perform in a certain way. This is the effect. So this is the example. This side input, and this is the plant or process. This is the plant or process. The input command, what is the input command? Input command, steering and wheel rotation. And plant, this is the car movement. And output control, direction of travel. And this is the variable output. This is the variable output. This is the very important word, variable output. So input or controlling variable, the applied signal generated outside the plant. This is the outside the plant applied signal, or excitation signal that is applied to a control system. This is the control system, that means plant or process, to get a specified output. This is the specified output is called the input, and input cause the plant to perform in a certain way. This is the effect of the system. So basic definition of the control system, another definition, output or control variable. This is the actual response that is obtained from the control system due to application of the input. To get a specified output is called input, and input is cause and the output is the effects. This is also very important sentence. Input is the cause, input is the cause, and input is the cause and output is the effect. So another definition, this is also output and output variable and control variable. This is control variable. Same example, input command, steering and wheel rotation. This is the plant or process, and after operation, this is the direction of travel, and variable output, this is the output controlled. And what is plant? What is plant or process or mechanic or machines? A plant is a control system, is the combination of process, body, mechanics, a physical object, systems, or process that is to be controlled, and actuator, which is a particular quantity or condition, is to be controlled. A plant is often referred to with a transfer function which indicates the relation between an input signal and the output signal of a system without feedback. So this is the example. Again, this section, input section, and this is the output section, and this is the plant or control system and the process or machines. This is the plant part or process part. So what is the transfer function? Output, this section output by input ratio is called the transfer function if all initial conditions are zero. So what is the output? What is the transfer function? And this is also called efficiency. Efficiency. What is the efficiency? Output by input, and this ratio always less than 1. So this is the plant definition. A plant is in a control system is the combination of process, body, machines, and a physical objects, a system or process that is to be controlled. It is to be controlled. So this is the plant definition. And another definition, reference input and command or command. It is the actual input signal which is applied to the control system and represents the reference value or variation of a controlled output. And what is disturbance input? It is an unwanted input which acts the plant output of the systems. This is the example again. This is the input section, steering and wheel rotation, and this is the plant process or control system, and this is the direction of travel, output response, output control, and variable output, and this is the disturbance by the wind, and it is the unwanted input. This is also unwanted input which affect the plant output, and this wind affect the movement of the car and affect the plant output of the systems. What is open loop control systems? That means in this case, no feedback path. In open loop closed control systems, the plant output is not feedback to the input. So an open loop control system is one in which the control action is independent of the desired output. So in this case, no feedback path, just input signal. This is step in impulse, parabolic, sinusoidal, any type of input you can apply, and this is the controlling section and controller part, and this is the actuating signal, and this is the plant or process and physical object, and this is the output system signal. And this type of operation is called the open loop control systems because no feedback, this is the feedback path. In this case, no feedback. That's why this type of control system is called open loop control systems. And next, closed loop control systems. In closed loop control systems, the plant output is feedback to the input. So in closed loop control systems, the plant output depends on the control action of the system, and the control action is dependent of the desired output. So this is the actual block diagram for closed loop control systems. In this case, this is the reference input and this is the error signal. Reference input minus feedback is called the error signal. This is the amplifier and this is the controller, and this block plant or process, and this is the controlled output. In this case, this is the feedback path. That's why this type of control system is called closed loop control systems. This type of control system is so the block diagram of the closed loop control systems. And again, feedback control systems. That means closed loop control systems. A feedback control system is a system where the output is feedback to the input and whose output is controlled by its measurement as a feedback signal. This feedback signal is evaluated with a reference signal to produce an error signal, which is filtered by a proper controller to produce the system's control input. A control systems are usually negative feedback systems. The oscillation are the examples of positive feedback systems. This is the negative feedback control systems on negative feedback control system example, and this is the block diagram, reference input. This is again error signal, and this is the comparator or summing point, and this is the control unit, and this is the actuator, and actuator signal or output signal actually plant or process input signal. This is the overall output signal, and this signal feedback is called by sensor, and this is the negative feedback. So this is the feedback control system concept. Then what is servo mechanism? A servo mechanism is a negative feedback control system in which the control is some mechanical position, and therefore a position control system is servo and as synchronous with the servo mechanism. So what is servo mechanism? A servo mechanism is a negative feedback control systems in which the output is some mechanical position, and therefore the position control system is synchronous with the servo mechanism. So what is process control? What is process control? An automatic control systems in which the output is a variable such as temperature, pressure, flow, liquid level, or pH is called a process control systems. What is process control? Then control laws or strategy. This is the strategy where for a set of predetermined policy is used by the controller to regulate the control signals. And what is MIMO system and SISO system? MIMO means multi-input, multi-output system, and SISO means single input, single output systems. And linear and nonlinear systems. This is the lecture number of 01, nonlinear control systems lecture. Regulator. What is regulator? It is a systems or arrangement in which there is a constant steady state value for a constant input signal. This is the regulator definition. And then linear and nonlinear concept. What is linear control systems? A control system is called linear. A control system is called linear control systems if it satisfies or follow the principle of homogeneous property and as well as additive property. So if follow the homogeneous property and as well as additive property, then we call linear control systems. What is additive property? If x, y, and z be the domain of the function f, then we can write f of x, y, z. F of x plus y plus z equals to fx plus fy plus f of z. And what is homogeneity property? A system is said to be homogeneous if we multiply input with some constant k, then the output will also be multiplied by the system or by the same value of the constant, that is k. And what is the equation? This is the f and function x multiplying by k, then f of kx equals to k into function fx. This is the homogeneity property. The principle of superposition is a combination of the above two properties. If a function is satisfied the above two properties, it is said to be linear in nature. That means additive property and homogeneous properties. Then it's called linear properties. And what is nonlinear? And what is the example of the linear control systems? A purely resistive network with a constant DC source, because this circuit follows the principle of additive property and homogeneous property. If all the undesired effects are neglected, and we get the linear voltage and current. That's why this is linear control systems. And what is nonlinear control systems? A control system is called nonlinear control system as a control system if it does not follow the principle of homogeneity property and the additive property. In real life, all control systems are nonlinear in nature or nonlinear system. So their linear control system only exists in theory purpose. Example, lecture number 01 in nonlinear control systems. So this is the important sentence. In real life, all control systems are nonlinear systems. So the linear control system only exists in theory purpose, only theory purpose. What a control system must have input section. A control system must have input, that is reference input, also called the set point. Input means reference input or set point, and output, plant output signal, which is measured by the sensor, and ways to achieve input and output objective, and control action. Controller output is the actuator signal that drives the plant. This is the control action and plant. These are all the control systems must have. So component of the control systems: error detector or sensor, servo motor, tachometers, synchros, potentiometer, modulator and demodulator, stepper motor, resolver, position encoder, actuator. These are all components of the control systems. And what is the elements of the good control systems? For better output response, ever pilot control systems must process certain basic elements. These basic elements are feedback elements, error detector, plant or process. Control must be objective. prompt reporting of the direction. Control should be forward-looking, flexible control systems, and the economical control, strategic control point, and control must be simple to understand. And control should focus on workers. Absence of any one component, the whole systems may wake. So these are elements for the good control systems like feedback control, error detector, plant or process, etc. Requirements of the good control system. Why control system required? Good control system. Accuracy. This is the very important. Accuracy is the very important for a control system part. By feedback elements, accuracy can be improved, and error detector should be present in the control systems to increase the accuracy of the system type of the control systems and any type of the control system. And sensitivity, this is also important part. Internal disturbance or any other parameters always changing by change in adjacent conditions. This alter can be expressed in terms of sensitivity. So sensitivity is the very important. Another section, noise. For better performance, a good control system should be able to decrease the noise effect. So this is our very important and requirement of the good control systems. Stability. A systems or scheme is said to be stable if its overall output is under control. Otherwise, it is said to be unstable. And bandwidth. Bandwidth, another section for good control systems. Bandwidth of a control system, mainly the operating frequency range, and it should be as large value for good control systems. Another section, speed. A good control systems generally high speed, and it is the time of achieved its stable output. That is, in this case, the transient period is very small. And oscillation should be small for stable or constant output. And others component for good control systems like flexibility, acceptability, integration, economic feasibility, strategic placement, and corrective action, etc. These are all for good control systems. So thank you.